All right. So let's start off with the homework. So I wanted you to evaluate some arcsine values. Now, I didn't tell you how to evaluate it, so you could have used the unit circle. I'll go over that. Or you could have just punched it into the calculator. There's a few ways you can do that depending on what kind of calculator, and I'll go over those as well. All right, so the first one we have is the arcsine of √3/2. So remember, if we're looking at our unit circle, sine is the y values and cosine is the x values. Okay, it's kind of, right, you think sometimes sine comes first, so that should be x, but no, sine is the y values. So what you're looking for is, where is my sine value? 3π/2. So we bring up, nope, that's not it, the unit circle, and I just closed it out. So bringing out the unit circle, again, I'm looking for, where is my y? 3π/2. I'm sorry, 3/2. Right, so we actually have a few instances where my y is 3/2, √3/2. Okay, so here, when my angle
Murray,
is
you're not
equal
showing
to,
anything.
oh, haha, thank you.
Let's say, is it my Wi-Fi or something?
We good now?
Yeah, I can see it.
Okay, all right. My apologies. Okay, now that we have the unit circle, right? So we look at the y values, and you're looking for 3π/2. So I have one over here at 120 degrees, or 2π/3. And then I have √3/2. I keep saying 3π/2. We have √3/2 over here at π/3, or at 60 degrees. So just remember how we had it yesterday. Okay, I'm looking for values of sine in between -π/2 and +π/2, or -90 degrees and +90 degrees, right? So I'm only kind of looking at this, the right side of my unit circle, if I'm talking about arcsine. So considering that, then I only have one positive √3/2, and that would be up here. So you could have given me two answers. I did not specify if I wanted the answer in radians or in degrees, right? So you could have said π/3, which, if you calculate it, should give you 1.047, or about 1.05, right? Or you could have said 60 degrees. So let's punch it in the calculator and see, make sure we get the same thing, right? So remember, arcsine is the same as sine to the -1st power. Now with a calculator like this, I can type in the square root of 3 divided by 2 right away. Okay, I can type it in just like that. And because I'm in degree mode, I get that 60, right? 60 degrees is what we said. Let's switch over to radians. And we do get the 1.0471, whatever, 1.05. Okay. So usually they'll specify what they want it in. Do they want it in degrees or radians? Okay. And this time, you know, I didn't tell you. I left it up to you. Okay. Any questions about the arcsine of √3/2? Do you want me to kind of clarify that more, or can we move on?
I understand now, because like now it just clicked in my mind, like how, like
Okay.
in the video last time, how you got 11π/6. It just clicked in my mind how you got it.
Okay. All right. Good. Good. Any other issues? Anybody else?
So if we were to put π/3, we'd get 1.049. The whole thing?
Yeah. Yeah. Right. If we calculated pi divided by 3, it's pretty much exactly the same thing.
Okay, okay. I got it.
Okay, cool. All right. And then the second one, I wanted you to find the inverse sine of 0. Well, this one was a bit of a trick question, but if you punch that in, it doesn't matter if you're in radians or degrees, you get 0, right? So again, if we're looking at our unit circle, where is my y value 0? Well, it happens twice, but again, over here, this is outside of my range for arc sine, right? 180 degrees, I can't plug in, I can't get that as an answer, right? So the only time we have 0 as a y coordinate is at 0 degrees or 0 radians. So that one's 0 no matter what mode you're in. All right, any questions? Okay, you may be asked to do the same thing with arc cosine. So it's the same process. We just focused on arc sine. So real quick. Let's evaluate the arc cosine of, I don't know. Pick a number here. Nope, that one marked. Root 2 over 2. Right, so remember for cosine, did I give that to you? No, we only went over sine. Okay, I'll go over the cosine in a second. But cosine is a little different, but I'm looking for the x values now, where we have root 2 over 2. Right, so right away, my first x value that I see is at 45 degrees, or at pi over 4 radians. All right, and again, if you use your calculator, pi over 4 gets us 0.785. And if I did the arc cosine of root 2, root 2 over 2, we get the same value, right? So 0.785, and again, pi over 4, 0.785. Right. So I did show you the graphs of arc cosine, I think, yesterday. So let's pick up with some rules, and then we'll go into new stuff. I am a little disorganized today. I apologize. What happened to pencil? Here's a pencil. All right, so arc cosine. Okay, again, we have the same domain as arc sine, so it goes from -1 to +1, right? Or if you want to write it either way like that. Okay, but for arc cosine, remember for our sine and our cosine graphs are similar, but one is shifted over to the right. So in order to get one full rotation for the range of arc cosine, I'm not looking at negative pi over 2 to 2 pi. Now I'm looking at 0 to pi. All right, so the range, the outcomes for my arc cosine are a little different because now I'm only dealing with the positive half of the unit circle. Right, so for arc cosine, I'm only looking at this top half, the top hemisphere there, or the north hemisphere. For arc sine, we're looking at the right side, the right hemisphere. All right, or the east side, east hemisphere. Right, but if you have your calculator, you can always use that. Now, the one thing I did want to say is if you're using your phone, specifically an iPhone, and you were asked to calculate something like what we just saw, okay, it might be difficult to plug this in here. You're right over there, Naomi.
Naomi, you're on a mute.
You're not muted.
I'm so sorry.
All right. So plugging this into your calculator, if you're using your phone, might give you difficulties. All right, so what I would do is I would calculate this first. So let me bring it up. What's my calculator? Come on. All right, so I would do the square root of 2, calculate that. I would divide that by 2. Right, so that gives us a really long decimal. But I'm going to remember the first 4, so 0.7071. So here, you can actually do the inverse on here. Sometimes there's a second button in the blue area, or here you see inverse. Right, so it shows you all the inverse functions there. So you do cosine, and then I would punch in the 0.7071. And this is in degrees. Oops, and I got rid of it. Can I go back? Yeah. So it's really, because I rounded what I plugged in, it's not going to give me an exact answer, but this is very, very close to that 45 degrees, which is what we just found. Okay. Or if we were in radians, okay, I would do the same thing and I get the answer. I don't want to take up too much time though. All right. So there's a couple ways that you guys can do that. Any questions about that? All right, so let's see if we have enough time today to get this. All right, so because we now know the inverse of our trigonometric functions, we can apply those to actually solve equations. All right, so we have a few rules here. Okay, so it's going to be 3 rules, and each rule for each trig function. Right, so we can use our inverse trig as a property to eliminate other trig functions. All right, so if I'm looking for an angle, I can use inverse trig to find the angle. All right, so say if I had the sine of theta equals, I don't know, 0.5, right? Now we actually have a tool other than looking at the unit circle to calculate what that angle is, right? And it goes both ways. So if I have the arc sine of some x, then I take the sine of the arc sine and it eliminates, and I'm just left with x. Or if I have the sine of some angle, I take the arc sine of that sine and they eliminate. Right? And the same thing is true for cosine and tangent. All right, so we can use the arc cosine and cosine. And again, all of this is true if you replace this with sine with the -1. And probably from here on out, I'm not going to write arc cosine. It's too much. I'd much rather write the -1 sine. And then for tangent, Same thing. All right, so there's a lot there, but it's really saying the same thing, right? We just have to define the domain and the range like we did before. So again, we looked at the graph of arctangent the other day, but I didn't really specify. So for arctangent, our domain is all real numbers. I can plug anything into arctangent, but my range is similar to sine or arcsine, where I'm only going to get values from -90 to +90 degrees. Right, so if you see them next to each other, then you can automatically eliminate them. Right. So if we saw something like, I need to see, which I'm going to start doing. Right, so if you saw something like this with the inverse tangent of the tangent of pi over 4, right, that just leaves us with what's on the inside, the pi over the 4. All right, but sometimes they switch them up. So the last thing we'll do today is look at that. All right, so the last thing we'll look at today, we're going to evaluate the tangent of arc cosine of 2/3. So when we have something like this, where we have an inverse trig function and then another trig function that don't cancel out, okay, what we have to do is we have to imply or go back to SOHCAHTOA. All right, we're going to have to set up a triangle to help us solve the rest of it. All right, so we can draw a triangle. Now, they don't tell us what angle I'm looking at. Okay, I could be looking at this angle here. I could be looking at this angle. And in all reality, it doesn't matter which angle it is. Okay, so you can pick whatever angle you like. I usually like picking down here. Right, so I'm just putting this here as a place marker. There's no theta up here. All right, this is just kind of a reference point. So I want to calculate the tangent of this angle. But again, I don't have the angle. All I know is that the arc cosine of the angle is 2/3. So let's break this down. So this is telling me my angle, right? My cosine of my angle is going to be 2/3, right? That's the inverse of what we just did. That's what the arcsine of something gives us, is an angle. So if the cosine of an angle is 2/3, the cosine tells us the adjacent over the hypotenuse. We have the values for the adjacent and the hypotenuse. So my adjacent side is 2. My hypotenuse is 3. I want to find the tangent of this, right? This is just going to be my angle. That's what, that's my placeholder. So the tangent of this angle, well, I need the opposite over the adjacent, right? So we got to find the opposite side. Well, we have a right triangle. We have 2 of the sides. So we got to use some Pythagorean theorem. Just be careful. We're looking for one of the sides, so we're going to look for either the A or B. It doesn't matter. All right, so we get b squared equals 5, or b is the square root of 5. So I can put the square root of 5 in this place. So now I'm looking at the tangent. of my angle, right? And again, we use substitution. The angle is arc cosine of 2 over 3, which was our original information. So the tangent of this triangle now is going to be root 5 over 2. And that's our final answer. All right, so we use the information from the inside to construct a triangle. And then we use that triangle to fill in the empty spaces to find the tangent. Now, the last thing I'm going to leave you with is we can only do this if we have the inverse on the inside. If I have the inverse on the outside and I took the tangent of something, it's a little trickier. All right, so if we have the inverse on the inside, that helps us set up our triangle, right? This told us that my adjacent was 2, my hypotenuse was 3. We found the opposite side, and we use that for our tangent. All right, any questions? All right, so I'm going to give you one of these problems to try tonight. Similar to this, not much different, right? Just different numbers. All right, so you're going to set up a triangle, and then you're going to calculate the trig function. All right, and then we'll take a deeper look into that tomorrow, and we'll wrap up the basics of inverse trigonometry. And then next week, we'll take a look at more right triangles. All right, guys. So keep a lookout for the assignment that'll come up in a little bit. And have a good day. I'll see everybody tomorrow.
Bye.